Some projects will require you to detail steel mesh panels. Tekla doesn't provide a dedicated tool for modeling steel mesh, so there are a couple of common workarounds. In many cases, mesh panels are simply modeled as a solid steel plate to represent the overall extents. While this approach is quick, it doesn't look particularly realistic. Alternatively, you can model each individual mesh bar, but this is very time-consuming and can significantly increase the model size. In this video, I'll demonstrate a more efficient method using reinforcing bar mesh to represent steel mesh. We'll start with a rectangular frame that is parallel to the horizontal plane. Launch the Mesh tool and select the part to reinforce, then define the outline of the mesh panel. Press the middle mouse button to confirm next. Pick 2 points to define the direction of the longitudinal bars. You can adjust the lateral position of the mesh by modifying the cover thickness. The mesh aperture can be controlled by adjusting the longitudinal and crossbar spacing, as well as the overhang values. Now let's look at a frame that is inclined, such as one on a stair stringer. You can have the mesh run either parallel to the stringer or parallel to the horizontal plane. This is controlled simply by the 2 points you select to define the direction of the longitudinal bars. Next, we'll look at modeling bent mesh. If you need to create mesh with returns, such as ARC-style fencing panels, this can be done using the bent mesh. Start the Mesh tool as before, but this time change the mesh type to bent. This setting must be applied before modeling, as it cannot be changed afterwards. Now define the shape of the mesh. In this example, I've pre-modeled points to control the geometry. Press the middle mouse button, then define the extents of the mesh. You may notice that the result isn't quite correct initially. This is typically due to the cover thickness. Set the cover thickness to 0, and the mesh should align as expected. To adjust the mesh aperture, modify the longitudinal and cross distances, along with the overhang values. While this method of modeling mesh panels is effective, there are a few limitations to be aware of. The mesh must always be attached to a parent part and cannot exist as a standalone object. Because this is treated as reinforcing mesh, it won't appear in standard steel material lists or report templates, so you will need to update your templates if you want to include it. Your drawing settings may also need to be adjusted to display the mesh correctly. If you are working with a steel license, the mesh cannot be numbered. And finally, bent mesh can only be formed in one direction, so you won't be able to create returns on all 4 sides.